So let's start with the second video of .NET Best Practices video series. How can we improve garbage collector performance using finalize and dispose pattern? Okay, let me give you a context of what this video is all about. If you ask any .NET developer today that which is the best place to put managed and unmanaged resource cleanup, or which is the best place that where you can put your cleanup code, most of them will answer saying the destructor. Now the destructor looks the most promising place to put a cleanup code, but it leads to something called as the double garbage collector loop, and the double garbage collector loop impacts performance to a great limit. Okay. So what we'll do is that we will first start up with the theory for this video. We'll start up with theory of how the garbage collector works, how does the destructor works, how does finalize works, etc. And then we will see that how performance is impacted when we use the destructor and how performance is improved when we use the finalize and dispose pattern. Before we move ahead, let's try to understand the concept of generations. Now, when any new and fresh objects are created by a .NET application, they are moved to the generation 0 pool, or they are marked as generation 0. Now, at some moment of time, the garbage collector runs and it wants to free the resources or free the object memory allocation. Now, for some objects, it will be able to free the memory, but for some objects, it won't be able to. For objects whose memory it was not able to free, it will move them or it will promote them to generation 1. Now again the garbage collector will run at some other moment of time, and if it is again not able to free memory resources of objects, those objects will be then moved to generation 2. So in other words, generation 2 signifies objects who are for a longer time in your application memory, and generation 0 signifies the objects which are recently created. In an application, if generation 2 objects are more than generation 0, that means that the application memory has not been utilized properly. So if you want to really say that this application is utilizing its memory in a proper manner, then generation 0 object should be more than generation 2. Okay, now that we have understood the concept of generation, now let me make a statement. When we use destructors, more objects are created in generation 1 and generation 2. Again, let me repeat what statement I have made. When we use destructors for cleaning up purpose, more objects are created in generation 1 and generation 2. Okay, how does that happen? So here's how the process is. New objects are created and all these new objects move to generation 0. Now at some moment of time the garbage collector runs. Probably it requires a memory, or there is a process, or there is a schedule in which the garbage collector will run, and it will check, does this class have a destructor or a finalize? If it doesn't have a destructor, let's go the other way first. If it doesn't have a destructor, it will clean the memory, or it will release the memory of those objects. Now if it has a destructor, it moves them to the F reachable queue, that is the finalization queue. That, in other words, because these objects were not freed, they are promoted to generation 1. Now at some moment of time, garbage collector will again come back and try to see that if it can free memories, if it can release memory of the F reachable queue. If it cannot, then those objects are again promoted to generation 2. So in other words, the time garbage collector sees the destructor keyword, or the time the garbage collector detects that there is a destructor keyword, it does not free the memory resource by itself. It does not free the memory resource. It moves it to generation 1. So when you use a destructor in a class, and when you create an object of those classes, more objects are created on generation 1 and generation 2 than generation 0. And due to this, your memory utilization is not optimal. Now in the coming up session, what we will do is that we will actually create a class with a destructor, without a destructor, and we will see that how garbage collector allocates these memories, objects in generation 1 and generation 2. Now let's do a small experiment, and by this experiment we will try to see that how using destructors more objects are created in generation 1 and generation 2 rather than generation 0. So here's a simple class we have. This class is doing nothing as such. It's a simple bare bone. It has no functionalities, and we are creating 100 into 1000 objects of this class. So what we are trying to do is that we are going to load our memory, and then using CLR profiler we'll try to see that how many objects are created in generation 0, generation 1 and generation 2. So let's run our CLR profiler. In case you're new to CLR Profiler, please do look our best practice number 1 video where we explain CLR Profiler from basics. So let me go and browse the application. Here's my Windows form finalize. This is the same application which we had talked about previously, and let me run it. Okay, now that our application has ran fully and it has basically created 100 into 1000 objects. So let's close this and let's see object by addresses. Now object by addresses helps you to understand how many of your objects are created in generation 0 and generation 1. Now you can see over here that majority of your objects are created in generation 0 and there are some objects which are created in generation 1. So in other words, your application is currently utilizing the memory properly and your garbage collector is doing its work properly because your most of the objects are in generation 0, and which is a good sign of performance for application. Now let's tweak the application a bit. What we have done is that we have just added a destructor here, and let's compile this and let's run our CLR Profiler. Let's go to the application. Let's run it. It has created 100 into 1000 objects. And now let's see object by addresses. Now if you click on object by addresses, now there's a big change here. You can see that the generation 1 object has increased more than generation 0, which says that by adding destructor, your more objects are now moving toward generation 1 than generation 0. In other words, this is nothing but more of your objects are moved in the F reachable queue. So that means that your memory is not utilized properly. And remember that over here my class was not doing anything specific. It was not doing any kind of functionality. But in case your class is doing some huge functionality, then definitely you will also see generation 2 allocation over here. We can avoid the objects being created in generation 1 and generation 2 using the iDisposable interface. So what we do is that we implement the iDisposable interface and we override the dispose method. And in this dispose method, we are going to write our cleanup code. Now we have created a public method called dispose, which will be called by our end client for cleanup. So as soon as the object is created and used, it will call up the dispose method for cleanup. And inside the dispose method, I am calling up the dispose method with the flag, that is the dispose method of iDisposable, which is doing the cleanup. And once the dispose method has been called, I am directing, or I am telling to the garbage collector, please do not call destructor by using the suppress finalize method. So when you call gc.suppress finalize, you mean to instruct the garbage collector, you are instructing the garbage collector that please do not call the destructor. So let's build this project and let's go and run the CLR Profiler, and let's see that what results we are seeing. Now it should show more objects in generation 0 than generation 1.